This is part 1 of section 5.6, Law of Cosines. So we're going to start by stating what the law of cosines is, and then which triangle congruences that we use for it, and then we'll be looking at some examples. And we're going to end this section with talking about how law of cosines and sines is related to finding area. So let's start by listing what the law of cosines is. So we're going to let capital A, B, C be a triangle, and it can be any triangle. Doesn't have to be a right triangle, doesn't have to be an acute triangle, just a triangle. And we're going to assume the sides and angles are labeled in the regular way. So like we stated in the law of sines, we have capital A, B, and C are the angles, and little a and b and c are the sides opposite those angles. So then there are 3 ways to write the same law of cosines. So the first one is a squared equals b squared plus c squared minus 2bc times the cosine of angle A. A second way is to say that b squared equals a squared plus c squared minus 2ac times the cosine of b. And the final way is c squared equals a squared plus b squared minus 2ab times the cosine of c. So as you can notice, the side that we're solving for is squared, and then on the other side of the equal sign we have the 2 sides squared, and then we're subtracting off 2 times those 2 sides, and then the key to notice is the angle we take the cosine of is the same as the side that we're trying to solve for. So if you notice, what we have here are 2 sides and an angle. So that leads us to the next part, which asks us, with which triangle congruences do we use the law of cosines? Well, if you remember from law of sines, we used angle, angle, side, and angle, side, angle. So the other 2 that we did not use are side, 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 and side, angle, side. Why do we use the law of cosines to find angles? And here is the important thing, and why it's better when we have more sides than angles, because with the law of sines it was better to have more angles. And the reason for that is, if you think of the arc cosine function, remember that's the inverse cosine, and how it's defined, if you recall, it's defined from 0 to pi. Okay, this will give us obtuse angles and acute angles. So it'll give us any angle that is in a triangle, because they're anywhere from a little more than 0 degrees, a little less than 180. So that, remember, all 3 angles have to add up to 180. When you're doing inverse sine, that was defined from, actually I make that up, negative pi over 2 to pi over 2. So you are only getting an acute angle in the calculator. It was either negative or positive, so then you'd have to add on to it with the calculator. You know, if it's negative 30, that's actually how much is that, and if I'm in the second quadrant. So it's just much easier to use the inverse cosine. So that's why we use it with the 2 that has either all 3 sides or 2 sides and an angle, because it's easier using the law of cosines to find the other side. Hopefully I'm getting distracted here a little bit because I feel like maybe that is coming out of my picture. Hopefully it isn't. I'll try not to write so close to that right edge. Okay, so let's do an example. It says a copy example 1 from page 443, but I'll go through it with you. So the problem asks us to solve triangle ABC. And we're given certain values. So let me just draw a triangle and I'll list everything that's on there. So the triangle looks something like this in the picture. Here's A, here's B, and here's C. And then we have these that are given. Side A is 11, side B is 5, and angle C is 20 degrees. So we have here side, angle, side. We have the 2 sides and the included angle. So we can use the law of cosines. And so the easiest thing to start with is to find the side C, because we have everything that we need from our law of cosines here to find C. We have A, we have B, and we have angle C. So we have all the parts that we need. So let's go ahead and do that. So we're going to start with C squared equals A squared plus B squared minus 2AB times the cosine of angle C. So you're just going to fill everything in, take the square root, and you're good. So C squared is going to equal 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of 20 degrees. And when you multiply that all out, you get 42.63, and then you're going to take the square root of that. And let me just give you a little tip here. I'm going to put this in the calculator. Is you're going to write a rounded answer there, but in your calculator, I would totally recommend that you don't do that, that you leave it in your calculator. Don't like clear out and put in, whoops, I didn't mean to hit that. Clear out and put in the rounded answer. So let's let that calculator open. I'll show you exactly what I'm talking about here. And I like to see that intermediate step. I'm going to be seeing that. I'm on a loaner laptop, so that's going to keep popping up whenever I open anything. Okay, so we're going to do, in our calculator, we are going to do 11 squared plus 5 squared, so I'll just put 25, minus 2 times 55, which is 11 times 5, times the cosine, and I want to make sure, oops, I'm in radians right now, so let me switch that. I always look at that at the top before I put anything in. Times, so I'll go over here now. There we go. Times the cosine of 20 degrees. And I'll hit enter, and you can see I have a lot bigger decimal than 42.63. Then what I'll do is I'll just take the square root of that, and I can round that way. It just becomes a lot more accurate, your answer. All right, so that's side C. So now I can write that down. So that's 6.53. Now what we have to do is we have to find the other two angles. Now you have two options here. You can use the law of cosines to find an angle, and then to get the third one, subtract from 180. Or you can use the law of sines, because you now have enough information to find a second angle. But let me caution you about using the law of sines. You have to be careful about the order in which you do it. When you have all three sides and one angle, you want to make sure that you're using the smallest side to find the smaller angle, because as we stated earlier, the inverse sine is always going to give you an acute angle. So you want to make sure it's possible that the angle A here across from the 11 is going to be an obtuse angle, and you won't find that out from the law of sines. So a lot of times when I have side angle side, I will just use the law of cosines again to find an angle, and then the third angle is real fast. So I don't know if the little bit of time that I'm using the law of sines really benefits me, because there is a possibility that I could choose the wrong side to work with and get the wrong angle measurement. So you want to be careful with that. So our second step is to find angle A, and I'm going to find the larger one first. And I'm going to do that by using the law of cosines again. Now, there is a form of this, if you want to memorize it, that's solved for cosine. And it looks like this, if you want to memorize this form. And it would be the same, you just interchange the angles. So cosine of A is C squared plus B squared minus A squared all over 2BC. If you don't believe me, go through and figure that out. And the reason why the signs would be all backwards, because you're going to subtract the B squared, subtract the C squared, but remember you have that negative sign there. So this form is what I'm going to substitute into to find my angle A. So I'm going to start here, and I'm going to say that A is going to be the inverse cosine of that fraction. Is going to be, so C squared, well actually let me write them in the same order. So that's going to be 6.53 squared plus 5 squared minus my A squared, which is 11 squared, all over 2 times 6.53 times 5. And I'll just put that in my calculator just like that, and I get that angle A is equal to 144.8 degrees. Because what I'm going to find from the numerator, that the numerator will be negative. So I know if I'm taking a negative inverse of cosine, that it'll be an obtuse angle, because cosine is negative in the second quadrant. So then, let me just be careful here, make sure you guys can see that number. I keep running to the edge of my screen. Now what I can do is find the other missing angle, find angle B. So all I'm going to do is take 180, and I'm going to subtract from that my 20 degrees and my 144.8 degrees, and I get that angle B is going to equal 15.2 degrees. So that's basic problem solving using side angle side.